Now we're going to go over the homework assignment that was for making the hexadecimal to binary converter. And so this first one is Evans, and so I just ran it. You can see it says type a hex number here, and I type FF, and then it returns the right answer, which is 256. So let's see how it works. So there's a conversion function here, and this is nice. Some people are not writing this first line, which is fine, but this first line lets you run your code, lets you execute it from the command line. You don't have to explicitly call the Python interpreter. So this z variable that he has here is going to basically work like the exponent, and decimal number starts out as 0, and then he adds to it until you've added, a times 16 to the 4th power plus b times 16 to the 3rd power plus c times 16 squared, etc., etc. So each time through this loop, this is the main loop, here the hex symbol, or the hex digit as a string, gets converted to an integer value, the corresponding integer value, if it's a letter, and otherwise he just converts it to an int in this statement right here. So as an integer, convert it to 16 times the current exponent. Remember that starts as 0. And so the first thing through is going to be the least significant digit, and that's why he reverses the string here. And so this is, the next summand in that expansion, sum of coefficients times powers of 16, and now this adds it onto the total and increments the exponent, and it's done. So here's the I/O part. Great. So I'll pause this, and then we'll go to someone else's. So this is David's, and I've run it a couple times here, and it takes the input from the command line. I think David always writes super error-resistant code. I bet this thing works even if you do like 0x or something like that. Oh, it doesn't, but it does give you a helpful message. Hexadecimal number can be of the form. Oh, you know what it is? I typed O instead of 0. That was my bad. So that was the correct response. Yeah. Okay, so let's see what it looks like here. Oops, there's no such program as vom. Okay. So this is part of the error handling. Error is another one of those words that I sometimes can't pronounce right. So David does the conversion from the string hex to the corresponding array of decimal numbers by using this dictionary. So the exponent starts out like this, and here's hexed. What is hexed? Hexed is the input, so it's the thing to be converted, and it works kind of like Evans, except David counts down instead of counting up, and for that reason he doesn't need to reverse the list. So neither approach is superior to the other, but so now do this stuff. So this is where he actually does error checking to see if the user typed in something that makes no sense. So maybe I'll try that after I exit here. And so it parses the command line arguments. Okay. So let's play with the error checking some more. What if I type in like something I shouldn't, like JJK? Yeah, so it recognizes that that's nonsense. Okay, great. So I'm going to pause this and go to the next one. So this is Julie's solution. And so here's the function that converts from the hex character to the equivalent decimal value. And So here's the function that actually does the conversion. So just like David, it looks like Julie's counting down, and total must be the total. So num is just a temporary variable that holds the conversion to decimal number, and now you add to the total, 16 to the appropriate power times the appropriate coefficient, and then decrement the power. It looks great. And so you can tell that Julie knows C. This is very C-like. And here's main. Okay, so it works great. And I'm going to pause this and go to the next person. So this is Sam's code. Sam did the reverse of the assignment and wrote a program that converts from decimal into hex, which is interesting. And I really like this function convert, which takes it takes a number between, so here's where it gets called. It takes a number between 0 and 15 and translates it into the appropriate hex character. And he's using ASCII codes here. So the ASCII code for the digit 0 must start at 48. And so if you have a number that's in the range from 0 to 9, then this will give you the character which is A places after 0, which will be the appropriate digit. And if A happens to be bigger than or equal to 10 or less than or equal to 15, so 87 must be capital A minus 10. So it must be 10 less than the ASCII code in decimal for uppercase A or lowercase a. And yeah, so that's really brilliant. So the convert function is great. And the algorithm that he's using to do the conversion is, repeated division and then remember the remainder, and then you, at the end, you just write down the remainders in reverse order. So that's the algorithm that's being used here. So this is Michael's work, and it's nice and short, and it would be even shorter without this these debug things. So the conversion from the letter to the corresponding decimal digit happens through this dictionary, and he uses sys to get the hex number as a command line argument. And this is the sort of familiar method of counting down and going up through the list of corresponding decimal digits. And yeah, it's great. So